Hello everyone, I hope you can hear me okay. If you just type in the chat box just to make sure everyone can hear, just a yes, you can hear okay, that would be great. Fantastic, great. Ahmed, yes, all good. Jason, yes. Ali, brilliant. Sam, thank you. Excellent. Okay everyone, thank you very much for joining us today. Good afternoon, and thank you for joining FEDS. This is the second in a series of webinars, Drone On. And today I'm going to be presenting a unique and exciting drone for drone mapping. It's going to be about the EBX system, and we're going to talk about how you can plan, you can pilot, and you can process. Three very important stages. Just to introduce myself, my name is Scott Henderson. I'm the product sales manager at FEDS. I have nearly 7 years experience in the drone industry from the UK. Recently, I joined the team to assist in the growth of the company in the product side. So you'll see a lot more of me as time progresses on social media, through webinars. I'll be getting in touch with you individually as well. So very much looking forward to getting to know you all. In the webinar today, I have my colleague Dan Casey, if he's joined or not, but he's the FEDS Business Development Manager. There's probably some in the room you'll already be aware of Dan. You may have worked with him in the past. He's going to be assisting me on the questions you may have during this webinar. And last but certainly not least, if Chris has already joined, I hope he has, but he will be joining in due course. Chris,
hi, Scott.
Oh, fantastic, Chris. How are you doing?
I'm good. Nice to be here.
Yeah, great to have you along. Just to introduce Chris to everyone, he's the regional manager for SenseFly, and that's for Europe, Middle East, Africa, and the Indian regions. So a lot on his plate. He's worked for the company for over 6 years, and he oversees a team of managers, and they are, without doubt, the most respected and experienced fixed-wing drone company in the world, and they're an absolute pleasure to deal with. So without further ado, today, I don't want anyone to be shy. Now, you can use the chat box at any time. If you want to type in a question whilst I'm going through the slides, please feel free to do so. This could be about the drone, it could be about your company. It could even be about a problem you face with your business. Maybe you just want to know how this fixed-wing drone is going to solve that. Well, please feel free to put any questions in that box. Chris and Dan will be responding to the questions in the chat box as I go through. Towards the end, we're going to have a Q&A session. So Chris and I will talk out loud. We'll go through all of your questions, and we'll be happy to answer anything in a bit more detail. But that will be towards the end of the session. So what are we talking about today? Well, I'm going to go through SenseFly and FEDS, and who are we? You may want to know a bit more about this. You may already know that, but for those who do not know, this is going to be a basic crash course. It's going to be about our brand, our company, and our strengths, and also be discussing why fixed-wing drones lead the way in many areas. That's over mapping, surveying, GIS. It's going to lead into drones, sensors, data sets, and then I'm going to go run through the software platforms that help you produce the data, and also the benefits of the drones. And that's going to leave questions and answers towards the end of the session. So many of you may know the answer to this question, but who are SenseFly? Now, for those who are not aware, I wanted to share a few key points just so you can better acquaint yourself with the company. They are based in Switzerland, and that is a hotbed of drone technology, believe it or not. SenseFly were founded in 2009 and quickly became a leader in fixed-wing mapping drones. They were acquired by the Parrot Group in 2012. That's a company that's been pioneering innovation in the drone space for a long period of time. So that's only aided SenseFly. They're very much customer-oriented, and their understanding of needs of the customer base has always provided drone technology, and that satisfied the demands of surveyors, mappers, businesses throughout the world using that experience. With over 10 years, they've created fixed-wing drones that have adapted and improved. They've also matured to be class-leading and industry-proven. There's competition out there, but they don't have that experience that SenseFly offers. The new lines of the drones are modular, they're cost-effective, and they're rugged as well. And we're going to go into a bit more detail about this so you understand why they are class-leading. Some of the competition, they just can't compete in certain conditions. And who are Feds? Well, Feds stands for Falcon Eye Drones. We're the leaders in specialist drone services and solutions in the Middle East. Recently, drone-based asset management solutions provider Aerodyne Group, they invested in Feds. This is big news. So previously, we were ranked 7th in the world for survey and inspections. And this was done by independent drone researchers, Drone II. You can find that information online. But with a combination of Aerodyne Group, we're now considered the largest service provider in the world. So we're going places and we're expanding the business, and we're really looking forward if you can join us along the journey. We're growing a team operating in the Middle East. We have the largest fleet, that is, and our client base takes us over multiple industrial verticals. So we're also the part of the Drone Policymaker Board in UAE. We generally offer our customers a very high return on investment. This is done through our experience and expertise, and also our presence in multiple countries as well. We have partners in the whole MENA region. My role is going to be expanding the product sales within the region. So very much service-based, but I'm now expanding this product sales side. So you'll see, as I say, more of me and more of our product offers as time progresses. I'd say we would be the complete end-to-end solution providers. So we have experience in 3D mapping, and this is through to progress monitoring, inspection, years and countless thousands of hours of flight experience with our experienced team has allowed us to build a plethora of knowledge. And we use this knowledge to help our customers, particularly in this region. If I don't know an answer to a question, then my colleagues will. So that's the benefit with Feds. You get unparalleled experience working with us. So Feds and SenseFly, why is this unique? Why is this a good partnership? Well, we're exclusive dealers for the Middle East region. We've got this amount of knowledge I've discussed thus far, and the great supply and support that we have in combination allows us to keep you operational for longer periods of time, with little or no requirement for downtime. And the reason being is we can stock a lot of the SenseFly spares in the Middle East. A lot of the competition, you have to return to base. So you could be out of action for several weeks. Well, that's definitely not the case with us. You've got us on site here. If you need any help, expertise, training, we can provide that. We've also got SenseFly to back us up as well with their plethora of knowledge. So we really do work well as a team. We're capable of demonstrating for you in Dubai. We can showcase the EV platforms. We do have teams in the Middle East region. So if you are serious and you want to have a demonstration, we are capable of doing that on site. You only need to speak to myself. We've also got a lot of extensive knowledge on the Pix4D mapping solutions, and these go hand in hand with the aircraft. And I will go into detail in due course on these systems. But there's a lot to talk about today, so I hope you enjoy it. These are just some of the clients that we have worked with in the past. You can see there are many examples in front of you. Some of you in this room may actually be representative of one of these companies. I think it's fair to say, with all these customers across industrial sectors, I want to thank you, every single one of them. It's allowed us to help our business grow over the years. And we hopefully, we've been able to return some of that investment by allowing your company to grow and adopt new technologies. It's a very disruptive technology, drones, and their workflows are not fully adopted throughout all industries. I see these leading to future savings by adopting this technology. And even if you're late to the game, even if you haven't used drones so far, it's not too late to start saving money, because it really will improve your workflows. So, multi-rotors and fixed wing. Well, this is sometimes a controversial subject. What's best to buy for certain situations? Well, I thought we'd put these crosses and ticks in front of you to give you a visualization of what's good for which, and which you prefer for other solutions. Now, this is typically not black and white here. When you're talking about cost effectiveness of using fixed wing systems and you're surveying, and particularly when you're talking about the vast number of sites in the Middle East, and a lot of you present here will be undertaking surveying for very large areas, multi-rotors become very much unstuck, albeit they are cheaper unit per unit. However, you will need to use multiple units to cover or accomplish the same vast array of surveying capabilities a fixed wing will offer. One EBX, for example, you can accomplish up to 500 hectares in one flight, in one survey. How many drones, multi-rotors, would you require to do the same area? Multiple drones, that's the answer. So you'll see there that we do have better pricing for multi-rotors, but generally for surveying, they're not ideal. They're definitely not. It costs too much because you need too many of them. So why a fixed wing? Going further than that, what are the benefits of fixed wing drones do I see over multi-rotors? Well, longer flight time for a start. A fixed wing aircraft can fly longer on a single battery cycle. This makes them ideal for mapping large linear areas, maybe corridors. And you don't have to fly home as often for a battery replacement, so you can be a lot more efficient in your surveying. They also offer greater stability, so I'm not sure if many of you are aware in Dubai at the moment, there seems to be a bit of a sandstorm. But just to go into an example, if the conditions are less favourable and it's windier, then fixed-wing drones are generally a lot more stable in these conditions. They can fly more than multi-rotors can in certain conditions. Also, safer recovery from motor power loss. If you lose a motor, a fixed wing can simply glide to the ground. That's not only safer for the people below them, but also the infrastructure as well. If you're flying over an object and you lose power in a multi-rotor, generally that aircraft is not going to be able to glide down to the surface. So that's another major selling point. Again, larger distances covered. And this is one of the main considerations. Through cost effectiveness, you can use them for a larger area than you would do for a multi-rotor. Just to mention as well, particularly the EBX, and I'll go into this in a bit of detail, they are modular, so you can replace parts a lot easier than a multi-rotor. If you damage or break an arm on a multi-rotor, you have to replace the whole section itself, whereas you can replace a wing, or you can replace other parts of fixed wing systems, and you'll see that in due course. And also a better control of image quality. So comparing this to traditional and ground survey, your traditional methods, you would typically take about 500 to 600 points on the ground per day. So you can imagine a static LiDAR-based system or a photogrammetry-based system, and you don't have the images to back up that data. Well, now you have the opportunity, say in a 15-minute flight, you can take 1 million points, and you can have the visual data taken on board the drone as well. So compared to your traditional ground survey, using a drone is far more effective, far more less time. Well, it's less time restrictive, put it that way. And the process is cheaper. You don't need to hire a team over a long period of time. You purchase a drone, you train your team member up, and you can do that job within a day. So as you can see already, it's starting to shape up as a much more cost-effective solution. So why are we all here today? Well, the essential points I want to tell you or teach you all are, when you're taking into consideration using drone technology, what is the purpose of using it? Why do you want to use it for surveying, inspection, and mapping? It's easy to break it into these separate points. So first of all, for instance, if you're planning a subject matter, what is the flight path? How big an area do you want to fly? What are your requirements? Do you need 3D? Is it ultramosaic or is it multispectral? Once you have the answers to these, you can then define drone flight using the included motion software, and I'll talk about this in due course. You then need to pilot the drone. So after the initial planning, you understand the logistics, what you need of that area. Then you need to plan the drone to capture the information. So I'll go through some of the sensors that allow you to accurately map these areas of interest, so how you pilot them, and also using the software. And no drone will be complete without the ability to process the data as well. So it's all very well acquiring all this information on the area you want to survey, but how do you process that? Well, I'll go into detail on this in due course as well. And also, finally, after the processing stage, how do you act on this data? So you've got the drone, you've got the data, you've processed that data. What do you do as part of your process of compiling that information, and how do you allow it to improve your workflows and your efficiency? So I'll go through a bit of detail as we go through. So first of all, I'm going to go through the SenseFly products. I want to give you a bit of a background story on the drones themselves and how they're going to benefit your workflows. First of all, we had the Swinglet Cam, and that was launched in 2010. This is very revolutionary. It's simple compared to the latest iterations, and it combined a small digital camera and had a lightweight chassis, but intrinsically it saved thousands of hours of data that would be required by companies around the world. By simply taking a drone to the sky, saved money. So this was followed by the more common designs you see now. You have the eBee, and that was launched 2014, or just before then. And the RTK just following that as well. So that revolutionized the accuracy of mapping. The real-time kinematic allows you to use ground control points and improve the accuracy of your images by georeferencing them and triangulating that with a ground station. So every reference point is a lot more accurate than guesswork of your typical GNSS system, your global network satellite system. In 2016, we saw the advent of the eBee Plus and also the eBee-SQ. Flight times were increased. They're up to 59 minutes at this stage, so quite a competent little system. They also introduced different payloads. So you've got the likes of the SODA system and also the SQ. The SQ is short for Sequoia. So that system is bespoke. It allows you to use a multispectral camera system and a sunshine sensor. I'll talk about that in a bit of detail as we go through the presentation. And also the resistance, should I say, would be the EBX. This is the latest iteration from SenseFly, and this is the system we're primarily going to talk about today. And it's the combination of 10 years of R&D, of working with clients, understanding their needs, and creating a system that offers all things to all clients. These are some of the benefits of the system. It has a range of new sensors compared to previous iterations, and these sensors allow you to provide quality 3D outputs, thermal meshes, a range of different results. Using one chassis, you can actually purchase the EBX and then swap out your payloads. So if you have one platform, you have multiple use cases, no problem. The system's designed to allow you to adapt to what you need. With the new sensors, as I mentioned, those high quality 3D outputs are now capable, and we'll talk about them in a bit of detail. And also the endurance extension, which is enabled through a firmware update, and also higher capacity battery, allows for increased flight time, so up to 90 minutes flight time. This is coverage up to 500 hectares, and that's at about 400 foot, so quite a large area in which you can use these systems. And you can use more than one at one time, of course, remember that. A new software algorithm allows a drone to land a third of the approach used by the previous line of drones, such as the eBee Plus. This is ideal if you've got a smaller area in which you want to take off and land. But quite important, if you are going to land this aircraft, you need it to be rugged and capable of landing hundreds of missions and on all sorts of terrain as well. And everyone here will be made aware that the Middle East, you're not looking at topography of grass and foliage which can help protect the drone. No, this drone's designed to land on anything. To land on sand, on gravel, on tarmac, on your topography, or anything. And that's a great thing. So it's a very capable system in the MENA region. And also the simplified maintenance. So previously mentioned is modular. You can take the part, you can put it back together again. It's so simple to do. And we'll go into a bit of detail on that later on. So the range of sensors available include the SODA and the SODA 3D. So this is a clever system. It takes a SODA camera, and what it does is it allows it to then take 2 or 3 images. It allows it to take 2 obliques and 1 idea image. So it moves, and depending on the area in which you're flying, it allows you to capture side on and straight down, which is great. So it has a 1-inch sensor, very capable, captures a lot of information, 20 megapixel resolution. But the important thing is sometimes camera systems, and photographers in here will appreciate this, it's not all about your megapixel resolution. You can get smartphones now with 40, 100 megapixel, but each pixel needs to have a very high quality amount of light coming into it. Otherwise, it looks muddled and it looks cloudy and distorted. So, albeit 20 megapixels, but very high quality with that 1-inch sensor. That's important to take note of. To get a 3D image, you need to shoot above and beside the areas or objects of interest. If you're typically using a camera that's statically facing down, the sides of objects are not usually that accurate. So this system allows you, if you're using it for building modeling or for an area for build, or there are many examples, an opencast mine or whatnot, this allows you to get all angles of that area of interest. And you can provide that information available in a DNG RAW format, JPEG format, so compatible with Mac and also Windows as well. And each image is geo-referenced, so again, it's important to keep the accuracy of those images when you're compiling it for data as time progresses. So the SenseFly Soda 3D makes these large-scale 3D models possible. So you can see here images for development projects, for remodeling. It allows you to understand the area a lot more effectively and plan efficiently rather than being on site at all times. Your business can provide this data and then plan very effectively. Again, this is a basic file format, so this is done quickly, but it gives you an idea again of sides of objects and giving a bit more accuracy on that. And this is a bit more of a comparison of the point clouds that are taken using a traditional Soda camera on your left here and your Soda 3D camera on your right here. The Soda is very good for orthomosaics, stitching images together, perfect for that. If your data set requires 3D imagery, you need more point clouds to formulate those images. And on the right, every single dot there formulates more information to provide a more accurate 3D image. So quite important to note. There's another example of a 3D mesh and topography with varying heights. So it gives you a better idea of the landscape here. The Area X camera is the next sensor I want to just briefly go through, and this is more of a photogrammetry powerhouse. So talking about the Soda 3D and the Soda cameras, fantastic quality. The Area X is more of a DSLR comparison, much better for your aerial imagery because it has a higher quality image and lens, a higher quality sensor, much larger, and it allows you to expose more light into that sensor, and it has a faster mechanical shutter. So essentially for orthomosaics, this is a superior system to the Soda, and it's one I recommend to those who want much more accuracy in the aerial orthomosaics. And again, each image is geo-referenced. This gives you an idea of the type of quality of footage that it shows and showcases. And also here a comparison of the SenseFly Soda and the Area X. A bit more detail on the right, and this is, to make it fair, we've used 5 centimeters a pixel for fair comparison. So you can compare and contrast the accuracy that's achieved. Now this one's a bit more relevant. I wanted to find some quality footage based in the area, and this is from the Hatta Water Dam. This is in the Hajjar Mountains, I believe. You can see the bottom left there, I've taken a Google Maps reference as to where this is, and this was stitched together actually through Agisoft Photoscan, I believe. But it gives you an idea of the sense of scale of an area in which you can stitch together with complete accuracy, so you can plan and project for your building works and your sites. Here this was really impressive stitched image of a very large area as well, accomplished by SenseFly, the EP platform. So it gives you an idea of the sense of scale that can be achieved when you're stitching the images together, and ideal for this region. Next, we're going to talk about the QAT, and this is a very interesting combination of 2 sensors, your Soda camera and also a thermal camera as well. Now, what the use be for this? You can create geo-accurate thermal maps, say digital surface models, and this can be done using both of these sensors together. And one thing to bear in mind when using thermal technology, in particular in this region, you need to consider emissivity. So the sun will shine on objects on the surface, and if you're flying a drone in the daytime, you need to make sure that you're not using thermal. The sun will reflect off any surface temperature, and it will give you a reading of what the sun is heating the object. So when using this technology, I would always recommend doing it at dawn, when your environment is at a constant. But fantastic sensor. It's a Tau 2 sensor, 640 by 512 pixels, very high quality. It's radiometric, so it stores the information of the heat source per pixel. If you want to use this for assessing heat escape from certain areas, or the land and the heat that's absorbed through that area, so you can plan your building projects much more accurately. This is an example of the type of image you can create using a GUAT. So this is a radiometric mesh, and it compiles both the data of the RGB camera and the thermal camera. Here you can see the output of certain buildings burning a lot brighter than other objects in the area. So it gives you an idea of heat escape on certain objects. So it's a problem in the MENA region. But if you're looking at areas where you have underground pipe work, sometimes most of the time, this will emphasize the areas in which those pipes are leaking. So you can use this over traditional topography in the Middle East for inspection work. So very capable and very powerful system. Again, it's transferable. You can attach this system, you can integrate it to the EVX, and then you can take it out and you can use this sort of 3D camera. The Parrot Sequoia is a very capable and very small multispectral sensor, and it captures images across 4 defined visible and non-visible spectral bands. So you've got your typical RGB camera, your normal camera you would use in a drone, and also the green, the red edge, near infrared wavelengths. And why is this beneficial? For agriculture, for topography, this is a real key sensor to emphasize areas of crops that are struggling, and those areas of crops which need a little bit of attention. And I'll show you an image in a second. This sensor is compatible with the EBX. You can put the Sequoia inside there and you can adapt it. There is the EBS Cube for those who are interested in agricultural surveying. It combines the sunshine sensor as well, and this adds GPS data, an IMU, so it improves the accuracy. And it uses a sunshine to give a true value of light, rotation, and location, so it gives you that absolute accuracy. Very important for university studies, for example, and topography and changing the environment today. And this is an example of the footage that camera takes on certain crops. Now, it's quite important to note that the light spectrum will allow you to use certain bands of light that's not visible to the human eye. Here you can see that the vegetation which is dead or stressed reflects more red light and less near infrared light. So in this image you can see in the center that crops are struggling, and they're burning a lot harder and a lot more red when they struggle through photosynthesis. So the farmer here can then assess, and he can tackle the areas of concern whilst leaving the bright green and yellow areas untouched, where they're not struggling. The important part of learning how to use the drone is also in the processing of the data. So far we've talked about the drones and the sensors and what they're capable of doing. Well, this is eMotion, and this is the software that's provided with every EBX or every EB drone that you purchase. And it's the flight planning software that's used with the EB drone, and that's from SenseFly. It has advanced features to optimize results, so it helps your drone in the air quickly. It also includes all the functionality you need to collect and manage all the geospatial data. It includes intuitive mission planning blocks, flight modes for unique survey, but all mapping applications as well. It allows you a full 3D environment, so you can plan every single flight, and it downloads the latest data, and it allows you to store it on your computer, take it to your flying field, access that data, and then plan your flight. But also, the important thing is, it allows you to plan your flights in the comfort of your own office, in the comfort of your own home, before you go on site. It even has a simulator system, which I'll go into a bit of detail, and how you actually plan that mission based on the environments that you're faced with today. So you can try before you fly, so to speak. Chris, who's in the webinar today, I'm not sure whether or not Chris is going to be able to demonstrate this, but we were hoping towards the end of the session that we could demonstrate the eMotion software for you all. He was going to give us a brief one, but I know he's been having a few computer issues, so apologies in advance if this is not possible. So they have a saying from where I come from: all the gear, no idea. You can have all the equipment you need, but without knowing how to process this information, it holds no value. So again, we're talking about planning, and then we're talking about simulating. The included simulator allows environmental changes. You can put in wind speed, direction, the location, and you can make changes to the flight path and also how long that aircraft will take to do that area based on the current conditions in the area. So this is ideal. This allows you to plan ahead. If the wind's picked up and you were planning on steady conditions, that may affect your flight time. So planning it through the simulator, you might see you won't be able to complete that area. Whereas if you make a few amendments, then it would be possible. So this is a really good little platform. You can fly the aircraft as well. So once you've done all of the necessary calculations, you can save them to your laptop and to your eMotion software platform. You can then leave your office, you can leave your home, and then you can attend the site in which you want to fly, set up your equipment, and then essentially you're good to go. You've got all your parameters good to go. You'll need to, obviously, you need to make sure that you set a certain landing point, but this software allows you to do that on the fly just before you take off. And then it allows you to export your data. So once you've completed that mission and landed the aircraft, the eMotion software will handle all the images taken, and it will process it into a file ready for Pix4D Mapper or other 3D software platforms. It connects to your drone, or once you connect your drone to your computer, you can pull that information on board. Then you'll start the post-processing of that information. So you have your drone, you've processed the data. What next? You've got Pix4D, you've got other software platforms, but we're going to talk about Pix4D today. They go hand in hand with the EB SenseFly platforms, and they're an easy and intuitive way to create all this data. And you can capture it, and then you can use a multitude of ways in which to process this data. So you can see here, you've got data sets from orthomosaics. You can create multispectral images, 3D point clouds, surface models, even contour lines, and Maxbox as well, Maxbox tiles. Every image can be georeferenced as well, so for greater accuracy, and if you want to create a building site, this software platform allows you to have all those tools set so you can plan ahead. Pix4D Mapper is a software I'd recommend for any professional who wants to use it for 2D maps and 3D modeling. It's usually the software program we recommend when you're buying an EBX. We can provide training on site to help you understand the software. And we also recommend to anyone using the EB platform for processing data to use Pix4D Mapper as the main go-to point. You can see a lot of its key outputs here are all those that we've discussed so far. So this is the go-to software platform when using a fixed-wing drone. Going above and beyond that, if you're an agricultural surveyor here, Pix4D Fields is an additional benefit, allowing you to more accurately determine aerial views, indexing those multispectral camera systems. So this is another string to your bow if you want to use it for crop protection, crop production, farm management. This is tailored more for that sort of agricultural result. Pix4D BIM, for the builders here, allows you to create 2D maps and 3D models, visualizing your build situation on site. You also have a timeline, so you can view, you can measure, you can annotate, and you can share. So you can compare CAD drawings, and you can export them to BIM software, and you can analyze this data further. So a lot more accurate for your building analysis. But I've also, something I haven't got on this presentation, I have some exciting developments with an alternative software platform called Hangar Job Site, which will complement anyone wanting to use drones for building and construction sites. And more along the lines of using it for multi-rotors, but you can capture a building site over time and see any changes as the progress develops. And you can plan and you can prevent any errors in builds spotted before they go any further. So you can save a lot of money if you prevent any replanning. If you wish to learn more about this type of software, you can speak to myself or Dan Casey after this, and be following it up with a webinar in the future about this type of software. There's Pix4D survey as well. This is the last bit of software relevant, I believe, to the fixed wing systems, and this bridges the gap between digital photogrammetry and computer-aided design, CAD design, and transforms point data into CAD-ready formats. So this reduces overall surveying time, and you can pull this information from Pix4D Mapper as well. So anyone who wants to use CAD files and even LiDAR-based information, this software platform is ideal for you. So the EBX has optimized payloads for all use cases and customers. Sensors offer unique capability, depending on your scenario. For those watching today, you may see huge opportunities for cost savings and improved workflows. So you may think you need more than one sensor. And again, this is no problem. So any of these sensors are compatible with the EBX. You can start off with one, and then you can add to your portfolio as time progresses. The endurance extension unlocks a maximum flight time of 90 minutes, and it unlocks the feature in the firmware and also the use of the extended flight time batteries as well. So your typical batteries are 3,700 milliamp hour, and the extended batteries are 4,900 milliamp hour. And this allows you the coverage up to 500 hectares. It has a radial link range of up to 8 kilometers, and that's in ideal conditions. It's generally around 3 kilometers, but this is perfect for BV loss missions. To put an example how much this covers compared to a multi-rotor, you have up to 10 times the coverage of an area compared to a multi-rotor, and you have 75% to 80% quicker acquisition of data. And also it's about 3 to 5 times lower the cost than any traditional method, any terrestrial measurement system. So saving of money there. Imagine having a team on site for a week compared to having this drone on site for a day. You've saved your money already. Again, eMotion allows the EBX to land a third the approach, and it allows you to land in much smaller areas than its predecessors. So you take a steep approach if conditions are less favorable. It's great to see in real life. I've had the pleasure of seeing that, and yeah, very robust and capable system. RTK and PPK is an upgrade option. If you want more accuracy, you can use your ground control points if you already have them. But we can offer, together with a geo-based system, and this allows you, just one touch of a button allows you to set it up, accuracy down to 3 centimeters with the RTK and the PPK system enabled. So very capable for surveying. And there is competition out there that may claim to get better than that, but that is as good as you're going to get. And if anything, it's absolutely key to note that 3 centimeters is very accurate data sets. The system is rugged, so it allows you to keep on mapping, and it allows you to land in those harsh environments. Now the wingspan's about 116 centimeters. It's got a weight of about 1.4 kilograms. So there's minimal risk to the infrastructure you're flying over. And that's a great thing with the EBX compared to its competitors. It's lighter, and if anything happens, it's smaller. So it's less disruptive if anything were to go wrong. Now, it can also fly to winds up to 28 miles an hour, which also is class leading too. So again, typically for environments in the Middle East, today we had a sandstorm blow over, or you can have windy conditions. This is the drone, this is a tool of choice over the competition. And it's important to note that. The modular design allows for the swap out of parts without downtime. So in front of you here, you can see you can replace the wings or the autopilot sections and the body moldings with ease. A major benefit when ordering with feds, you don't need to send the whole drone back to the manufacturer. Some of our competition, you need to send the whole drone back, and it could take or delay you for weeks on end over your project. this allows you to get back up and running again in a fraction of the time. So you can even order extra wings when you first get your drone from us. So if you have any issues, just swap them out. That easy. And we have the team on site to also help you to swap those systems out as well. So do use us and consider us if you are buying extra parts, if you need any help with it. And maybe you want to future-proof your operations. If you're using these drones on a daily basis, always have a plan in place to have those peripherals, those accessories to keep your team running with minimal restrictions. So the EBX has been closely followed by dealers and customers from all over the world. And again, SenseFly's experience have allowed the SenseFly EBX to become the drone it is today. And without that information provided by the customer base, it wouldn't be as rugged, compact, capable, and key for cost effectiveness without this information. It's been tested in all sorts of environments continuously, including this region. And that's why you see the drone that you see today, based over the information that's been provided by the client base. And this is just one of the bits of feedback that has been provided by SenseFly by one of our customers at Green Aerotech. So quite a phenomenal system, and first accounts, I can't believe how strong the system is. So again, the important thing about planning and using a drone, again, in these stages, how do you plan it? What area do you want to observe? What's the flight path, the altitude, the area to map? What are the requirements? The output and the accuracy. Then, how are you going to pilot this area as well? What drone do you need? What sensors do you need? And then how are you going to process that information? What sort of software do you need? How are you going to process that information to then act upon? What are you going to find out about that information that's going to allow you to make those cost savings? You can clearly see today, you can plan that and you can pilot that using an EBX drone, using either of the sensors. You can then process it using Pix4D software and the eMotion software for the actual creation of the flights. And then you can act on that data. You're delivering accurate to 3 centimeter accuracy data for surveying and mapping. And there's nothing that beats a drone using over a large area over your traditional methods. So the great thing with this system is it allows you to do all this. It allows you to plan, pilot, process, and act upon that data with relative ease. And of course, using the likes of Feds and SenseFly, we're here to support you along that way. We're here to help train you, assess the stages between each of these points, so then you can become much more accurate and efficient in gathering that data set. I want to mention that we have some Ramadan deals today as well. So at the moment, you can get up to 23,000 dirham off for trading in your old EB. So anyone here who has an old EB system and wants to upgrade, we've got some huge discounts on that. We've also got a support businesses package at the moment. We're all aware of the current circumstances that the world's facing at the moment. So we want to help you all become more efficient and to get your foot in the door, so to speak. So after this webinar, you can chat with myself, with Dan, with anyone on our team, and we can send you quotes on any of the systems we discussed today. I would like to talk to you individually and know what your business cases are, and then we can tailor a package based on what your use case is. And we'll make sure that we look after you in terms of pricing as well. So how do you get in touch with us? Well, you can get in touch with myself, Product Sales Manager. That's my email address, scott@feds.ae, my mobile number as well, so feel free to call me. And if I don't answer, I will call you back. There's also Dan as well. If you want to talk more service provision and pricing, and Dan's your man. And of course, Christopher Thompson as well, Chris at SenseFly. If you have anything you require from SenseFly, if you have any research and development or any feedback on the platforms you want to provide, then Chris is your man for that as well. I want to thank you for joining our webinar today. This is going to be a time for questions and answers. I just want to find out from Chris. Chris, are you able to demonstrate eMotion?
I'm going to give it a go. So I'm going to share my screen, so if you can maybe let me know if you can see.
Okay, so what I'll do is I'll see if I can share your screen. fantastic host. Right, here we go, Chris.
Okay, so can you see my screen, everyone?
Not at the moment. If you share your screen, Chris, see if you can do it.
Sorry, share screen. Screen share.
Fantastic. Great, we can see it, Chris.
Okay, great. So thanks a lot, Scott, for that. I'm just going to basically do a quick emotion flight planning, as Scott said, really to show the power of the software. We know that you guys, when it comes to fixed wing acquisition and drones, there's a lot of choice on the market, and something that more often than not doesn't get as much attention as it should do is our flight planning software. So as Scott mentioned, Emotion is the flight planning software for EBX. It's completely linked to only our systems. So you're not going to be able to use this on any other platform on the market. And this allows you to do a lot of things. So I'm going to give you probably a 5-minute demonstration now to show you some of the real key features. There's a lot more that goes into it. So if at any point you feel that you want to have a private one-on-one webinar with myself or with Scott or Dan to do something tailor-made, or even to do a simulation of an area that you're thinking of using a potential fixed wing to do, we're more than happy to do that, and we really do encourage it. So we're going to kick things off here. You can see the main screen here. We're going to select our drone EBX. As Scott mentioned, there's a whole array of cameras that can be chosen with our system. So depending on what cameras you have for your EBX or your fleet, you can select them accordingly. So we're going to go ahead and select these 3 cameras here. We'll create our mission. Okay, so first thing to take note of is the 3D environment. I think this is really important because you can already see here, this is basically Switzerland, Lausanne, where we're based, where Sensfly is based, where I'm based. And you can see already that the elevation data is already applied on the 3D model. And we'll go into more detail when we do this flight simulation, why that's really important for when assessing, the safety of your flights and a lot more detail. So we're going to go ahead and do a mission over here where the mountains are, so we can show some of the really cool functionalities of our software. So just give me a sec. We're going to choose somewhere that has multiple features, so we can do a variation of mapping. Okay, so maybe let's choose here. So let's say we're on a surveying job. You guys have been given a contract by someone who wants you to survey multiple areas. So we had a question before on the Q&A, which we'll probably go into more detail after this. But why should I buy a fixed wing over 10 Phantom RTKs? Well, the reason being is that you'd need 10 Phantoms to cover the same area that one fixed wing EBX would do. You'd also require 10 operators if you're going to do it in the same time. If you want to use one operator, you'd have to do 10 different missions, so kind of defeats the object of having those 10 drones. And also you need 10 separate probably permissions, whereas with a fixed wing, you're doing one mission. You can do multiple blocks, which we're going to see now. And as Scott mentioned, you've got the possibility to increase the flight time from 60 minutes to 90 minutes. So the real advantages of a fixed wing is obviously the area coverage. It's the ability to do different sectors or blocks, because the drone can easily transition between these. It doesn't need to land. The only time the system needs to land is for you to swap the battery. So someone also asked me before in the Q&A, can I do 100 square kilometers with a fixed wing? Simply put, the answer is you can do whatever you want with a fixed wing. The largest project we've done to date, probably that I off the top of my head, other than maybe Feds is one in the Middle East with the agricultural project they did last year, which was a real beast. We did one in Tanzania as well, where we covered probably close to 100 square kilometers, which took a few weeks to do, but again was a lot cheaper than the manned aircraft, which again was in relation to the question. And a lot quicker than ground-based surveying. So again, drone technology isn't there to potentially be applicable for every single project. It's there to fill a void in between manned aircraft, in between satellite imagery, and in between terrestrial surveying. So we're there to be able to do I'd say probably anything from multiple square to all the way up to 100 square kilometer projects. Obviously, once you get up to those larger areas, you probably need multiple drones to operate. But our software also allows you to operate multiple drones at once. So again, you can be flying 2 or 3 drones at the same time and be maximizing that area coverage and be able to do those type of missions in 1 or 2 days, which again, compared to the price for use is probably your best option. So we're going to go ahead first, and the first major point when planning any flight is the safety aspect. It's the launch and the landing. Obviously, with any fixed-wing drone, like a plane, the launch and landing is where things, if they are going to go wrong, might go wrong. So you need to make sure that these are safe and that you've got a good amount of area. So here's a perfect example of somewhere where we'd want to launch and land. So it's a good amount of space. It's a good radius, nothing really blocking us. You wouldn't want to do it too close to the trees. You don't want to do it too close to the village there. And again, the power of the fixed wing is that even if you didn't have this option here and you were wanting to survey this area, you could potentially do it over here. And again, the drone transitioning from here to here and to do the mission is minimal in its battery use. So again, that's the power of fixed wing over quads. Is quads, the propeller is continuously operating, eating up that battery. So a transitional period for a quad eats up sometimes all of its battery. Whereas with fixed wings, it can transition relatively easily and minimize that battery use so that the majority of the battery is saved, most importantly, for your missions. So we're going to go ahead and set our key criteria. So you can see already that the system sets basically a home waypoint. So this is this little section here. This is where the drone will come to its final section. Where it comes, it will descend to 75 meters, and then it will choose its landing strip. So you can see here it's already given us a landing strip, which we can move accordingly, depending. We can increase or decrease depending. We can even add extra sectors. If, say, for argument's sake, we had this area that was applicable and then this area, you can add 2 sectors. The drone basically chooses its landing section within this triangle based on the direction of the wind. You can also change and move this whilst the drone is in flight, because the software is linked via radio to the drone. This will automatically upload or tell the drone of those changes. So again, as Scott said, you can do all of this in the comfort of your office. But most importantly, once you get to the field, because we're working with obviously a background map here and things may have changed or might be slightly different once you're on the ground, you can change this before the flight. So this isn't too important when you're doing a simulation, but it is important obviously before you go physically fly. The second section you can see there is the start waypoint. So again, this is where the drone will transition to once you launch. So again, you want this to be clear of obstacles, probably not best to have it in the forest or the woods there. So this is relatively good. So that's the first step in terms of creating that safety aspect. The second, which you'll see, is this circle which encompasses our area, and you'll also see this ceiling limit as well. So this you can basically associate with being an iron curtain, if you will, for one of a better phrase, but basically means that the drone can't physically leave this area and basically allows you to set this parameter. Again, if you maybe had an airport here or you didn't want other areas for the drone to go into, this means it's physically unable to go. And if it gets too close to this parameter, it will hold its position here. It will never leave this position. So this you can alter, and obviously here what we want to do, or what I want to do to show you, is to do a mission in this village, maybe a corridor mapping around this road here, and then a third mission on this elevated area. And we're going to try and do that all in one flight. So again, that's really to show you the power of the fixed wing over quads. So we're going to go ahead and increase this. Again, you can do it. Depends on regulations, and most importantly, the altitude limit is really dependent on regulation, because Switzerland here we have 300 meters altitude limit. UK, they have 150 meters. So really depends on where you are. You might also get special permission to do above those areas, above that altitude, sorry. So again, the software allows you, for whatever type of mission you've got, you can tailor make it. So we're going to go ahead and we'll keep this at 300. What you'll probably see in a bit, and it's good to see the warning signs the software will give you, is that if we actually decrease this down to 200, when we go to do the mission here, because you can see here our ceiling limit is cut off here. So we're going to just keep that there just to show you, for example's sake, what the software, the type of information the software will give you when planning the flights. So we've done the most important, in my opinion, criteria for when planning a flight. It's the safety aspect. It's your landing area. It's where your home and start waypoints are, and it's your iron curtain that allows the drone to stay within a certain radius and a certain ceiling altitude limit. Okay. So next, we're going to go ahead to the fun stuff, which is doing the mission planning. So the other really amazing feature of Emotion. And again, compared to maybe your DJIs and stuff, the real power, other than everything that Scott has mentioned with regards to the hardware, is this software. It allows you to do different types of customized mapping missions. And we saw some of the examples from the UAE that Feds have done themselves, and it truly is spectacular. And so that was done with real ease because of the power of Emotion. So we're going to go ahead and do a simple horizontal mapping. So say we wanted to map this village here. Okay. So we click on, first thing you can see is obviously the mission already area here sets the waypoints and the mission lines that the drone will take. Already on the left-hand side here, you have tons of data. So first of all, we're going to choose which camera. So let's say our mission in question here wanted a really good orthomosaic. As Scott said before, the Area X is really the camera geared towards the ortho side of things. Again, you could use the Soda 3D, and both of these cameras will provide you both orthomosaics and 3D reconstruction. So all cameras do the same thing, just some cameras are more geared towards ortho and more geared towards 3D. So we choose Area X. You're going to set the resolution of the mission. So again, this depends on the resolution you or your client wants to achieve from the mission. It also depends on regulation. So we can see at 2.5 centimeters per pixel. Our altitude of our drone will be at 118 meters. So let's say we're going to go up to maybe 236. This means we're at 5 centimeters per pixel. As you can see here, you can see our estimated flight time. Currently with this small block, we're doing about 9 hectares or about 0.10 square kilometers. Going to give us 30 photos, going to give us an estimated flight time of just over 6 minutes. If you decrease that, the drone is obviously flying lower, so the altitude changes, the number of photos will increase, the flight time will slightly increase. So you play around with this depending on your criteria, and this is the great thing about a simulator. You can do in your office, you can put a cup of coffee on or tea depending on your preference, and just play around with what you've got. So we're going to stay with this 4 centimeters per pixel. We're now going to customize our mission. Let's say we wanted to get this part of the village as well. So again, you just bear with me for 2 seconds. Sometimes it's a little fiddly with my mouse, but again, very intuitive. Okay. Okay, so we're going to finish just quickly that off there. All right, there we go. So we've done, you can obviously do different types of customized missions. You can again go into the 3D mode. You can see here that that's going to take us, that's nice, 10 minutes bang on. It's 59 photos, 0.15 square kilometers. So again, as Scott said, you've got 60 minutes with the normal battery. I always say, let's say 50 to 55, because you have to take into consideration weather, wind, that type of thing does impact sometimes the battery life. Obviously, if you've got the endurance battery, you've got all the way up to 90 minutes, and again, 85 maybe with wind conditions. But you've got a huge amount of additional battery left for this drone. So what would be the point in mapping this, landing, changing the battery, or launching again if you could do each mission one after the other? So we've done this. Now we want to do a corridor mapping of, let's say, this road around here. So we're going to go ahead, select corridor mapping. We're going to, and this is how easy it is. And again, this is for, a road. You can do this for pipeline. You can do it for anything that requires a narrow yet long area. We're going to click again here. Quickly, Area X is what we want. We want 4 centimeters per pixel. Okay, again, changes the altitude, changes the width of once the drone is taking the photos. We click done. Fantastic. So that's 16 minutes there. So we've got about 25 minutes already on the clock there with maybe 2 or 3 minutes transition time. So again, still plenty of time. So for our project, we want to now map the side of this. And this is a really cool feature. This is what I want to show you. You can see here that this is obviously elevated data. So we want to have the drone flying this, but more importantly for processing or reconstruction purposes, you need to make sure that every image is the same GSD. So you don't want to have a case where the drone has taken one image here where it's 10 centimeters per pixel and one here where it's 2 centimeters per pixel. We need to make sure that the drone does this. And most drones on the market, most softwares will make you have to painstakingly change each waypoint, each mission block to have each GSD the same. Whereas here, as we'll see, in our third mission block, again, we'll choose horizontal mapping, click this here. So again, it's most important when going against an elevated terrain, you need to make sure that the drone is taken flying like that. If you do the other way, it won't work. But we can already see if we select our area, okay, we want to survey this, fantastic. Sorry. Slightly fiddly with my mouse map here. There we go. Okay, we'll do this here. Okay, so we can already see that, look, it changes each waypoint to match the difference in elevation data, which is truly amazing. We're going to change this again to 4 centimeters, so we have a nice same image GSD for all of our project. And you can see then it will increase the altitude, but again maintains that slope with regards to the slope here. So that's using the elevation data of the background map. You can, of course, if you want more accurate elevation data, do a mission before doing this mission a bit higher and then import your DSM into Emotion. This software allows you to also do that, so you can have extremely accurate data. And it's probably important in areas maybe in the UAE or in the Middle East, where potentially in the mountainous regions the satellite imagery isn't up to date, and you may want to have up-to-date imagery to get the most accurate mission planning. So we can see there again, sorry, we're going to change that to area X so that we've got the same camera for all missions. We're going to change this again to 4. So we have an area there again of 0.31 square kilometers. It's again a 14-minute mission, so not so long. So all in all, if we just quickly go back, we've got 10 minutes for our first one for our village mapping. We've got 16 and a half or 17 minutes for our corridor mapping. We've then got 13, 14 minutes for there. So again, we're going to connect. Oh, so here, sorry, as I said before, multiple blocks outside of working area. So if we go here, we can see that, oh no, the drone's been told it can't leave here, so it's not going to be able to do this part of the mission. So that is easily resolved. We simply go, and you'll see this disappear in a few seconds once we get over the threshold. It's outside the working area as well, so we just increase this. Okay, there we go, boom, done. So we set our parameters, which is in accordance with what we want to do. Again, the software will tell you as and when you've not maybe potentially done something correctly. So again, it is very intuitive. And again, Feds or myself are there at your beck and call to be able to assist you with these type of things if you get into any problems, because a lot of you I know, and we'll probably see in the Q&A section, is you probably have very tailor-made missions that you want to do, and this is what this software is extremely good at doing, is it allows you to do those type of tailor-made missions. Okay, so we're going to quickly connect our drone. It's a simulation. Obviously, we had we're in the field. We connect our drone here, and if it was connected to the software, we'd have the serial number of the drone here. We'll start a simulation. Okay, so you can see now that the interface that we get, and this is the exact interface you will get when you're flying for real. What we do then is we assign first mission, fantastic. Second mission, fantastic. Third mission.
Pre-flight checks completed.
I don't know if you heard that. That's someone from the British Isles giving you your on-demand data. So basically you'll have someone giving you a voice command as well. So that is important because you're obviously going to be in between looking at the drone, looking at the PC, that type of thing. So you've also got voice commands. So we can see here that our estimated flight time for all of this, including the transitions. So that means launching, doing this mission, transitioning to here, doing this mission, transitioning to here, doing this mission. And there we're doing 0.15, 684 meter corridor, plus again another. So we're doing about half a square kilometer in horizontal mapping, and then half a kilometer in corridor mapping, all in one flight, and we're only at 49 minutes. So perfect for that 60-minute battery. It gives you that buffer. But again, imagine again if you had the endurance extension, you could increase this area. So we'll quickly simulate a takeoff, just to show you what happens.
Motors will start spinning. Going to mission.
So the first thing the drone will do will go to the furthest point of the first mission. So it always starts as far away as possible, which then allows, obviously, it knows at each point how much battery it needs to safely return. So say for argument's sake, you set this mission and it was at 50 minutes or 55 minutes, but the wind was particularly high. You can see the wind speed here. We're only at 3 meters per second, so nothing to feel worried about. But again, if you're at the very high end of the wind, the system's able to do the mission, but it will obviously impact the battery. For whatever reason, the drone will never, ever let itself just fly until the battery is drained and crash. It knows exactly at each point during the mission how much battery it needs to safely return home, and it will override all of your commands and do so if it needs to be doing. So you can see here, it's already started taking the images. You can see the footprint of the images, and you can see that there. That shows exactly the area where that photo is taken. And obviously, each image is overlapping the next. So again, for reconstruction purposes, we're going to have no issues, and Pix4D or whichever software you decide to use that processes georeferenced images will be able to do it no issue. At any point, you can tell the drone to hold. If you maybe saw a helicopter or anything in the distance, it will hold its position. Again, doesn't use too much battery, it's basically gliding. And you can then say, go resume mission. And it will just start exactly
Going
from
to mission.
Its initial point. So we won't go through all of this, obviously, because it's a little boring. But again, it will complete all of this, and then you can tell it to go land at any point.
Going to home waypoint for landing.
And for any reason, if you had to have it to go land, you can then, once you launch the drone again, just click resume mission, and it won't have to do all of this again. It will resume from here where it stopped. So we're just going to see here, it's going to choose its landing path like a plane, a linear landing. It will go out, and then final approach now, and it's going to go from around 120 meters on the normal and about 60 meters on the steep landing. It's going to descend, and our friendly British associate is going to tell us at each point how many meters it is from the ground. You can abort the landing, very importantly, at any point. You press the space bar on your keyboard and that will abort landing. It will regain its altitude and come back here, and then you can change this again if you feel that you've not set the proper criteria.
$50, $40, $30, $20, $10.
There we go. Our drone has landed safely. We've done our mission. We've done all of that in under an hour. We're home for lunch, and we've just sent all of our data the next day to our client, who's extremely happy. And you've been able to do this in a fraction of the time that probably any quad on the market will be able to do. And with this very powerful and intuitive software. So I hope I've shown you some of the key features of Emotion. Again, if you have any tailor-made requests where we can do a webinar one-on-one, I'm available at any time, as are Feds. And again, if you have any questions now, I'm sure some of you do. We're going to be happy to answer them in the Q&A.
Fantastic. Thank you very much for that demonstration, Chris.
Yes.
I think what we can do is we can go through the chat section, and we can go through some of the queries that some of you guys have had for us. Copy of the presentation. I'm definitely going to be sending this out to you via email. So for yourself and for your colleagues, if anyone you know have missed this presentation, I'll be sharing it with them. You'll get a copy of the presentation and also the slides as well. So we'll forward those on to you. Going through a few more of the questions. What is the requirement to unlock full 90 meters endurance for EBX? And I think, Chris, you've answered this already. Permission is needed in certain regions, is that right?
Yeah, so just a quick overview there again. It's regional dependent. It's basically probably available everywhere, but we do need permission in certain areas before we're able to activate a drone. The Middle East is one of them, but feds have acquired that permission, so that there'll probably be no issue at all. Basically, all you need to do is sign a sheet that confirms you know that once you're over that 60 minutes, the drone is considered dual use. We then send that to our Swiss authorities and usually give us an answer in 24 hours. Once we receive the green light, we basically then give feds the downloadable patch, which they will help you upload to your drone, which then unlocks the potential of the drone to be able to operate at that 90 minutes. And then you do obviously need the endurance battery to be able to operate up to 90 minutes. For whatever reason, if you want to just invest in the endurance batteries and not the extension of the endurance, you can use the extended batteries on a non-activated drone, if that makes sense. It basically allows you to then guarantee all cameras. So with the Duet T, the Soda 3D, obviously are heavier payloads. When you're using them with a normal battery, you're probably dropping to about 45 minutes. If you use the endurance battery with those cameras, you guaranteed 60 minutes with all of those cameras, and that's not with the permission side of things.
And also make sure you select the right batteries when you're charging them using the supplied charger. You want to make sure you're getting the right charging settings right for each one. Cost of the EBX, I can buy 10 Phantom 40K and cover 4 times the same area that EBX can cover in safe mission. My EBX is not VTOL until now, and I can use that anywhere. What's the latest price for it as well? To answer that question, myself and Chris will help you on that one, Ahmed. I think we responded to this, that having 10 Phantoms logistically is not an efficient way of processing a survey. The Phantom drone is very good for inspections. If you want to use one drone for a small area, then that will be a system that can't be beaten. Whereas the areas we're discussing, up to 500 hectares, to have 10 Phantom drones requires people manned on the ground to program them, to prepare them, and also to store and carry them as well. So you'll need to manage 10 batteries as opposed to 1 battery, and you'll need to manage 10 drones as opposed to 1 drone. And even though the DJI software allows flight up to 10 Phantom 40Ks, it's efficiency. And at the end of the day, you want to save time, you want to save money. And that's why one EBX can do just as good a job as 10 Phantoms, if not better. And that's the reason behind our explanation on that. VTOL is, it adds extra layers of complexity to any product. There are competitors out there that offer varying types of VTOL, increased dynamics in terms and complexity in terms of the way the motors are oriented. So they may rotate the motors, which adds complexity to the vehicle, adds weight to the vehicle, it reduces flight time to the vehicle. Some aircraft offer takeoff directly up, a whole aircraft faces up. That offers added complexity to the environments in which you can fly. So windier conditions, the aircraft is subject to more forces on the aircraft. It acts like a big sail. So it's not really a big problem because the aircraft now offers a third of the landing area that it used to. And if you're using this aircraft for surveying, typically you're using it in open spaced areas anyway. And if you want to use it as a VTOL aircraft, typically you'll be in a built-up area and you won't have the permissions to fly in those areas. It's not a bigger problem as some people make it out to be. And that's why Sensify use a system, and they've evolved it. It hasn't been revolutionary because it works and because of the data sets that people are requesting, because of the simplicity of the aircraft, you want it to work time after time. That's the reason why they haven't really focused on VTOL to date. I don't know if you can add to that, Chris.
Yeah, I think 2 points there whenever I get asked the VTOL question. One, as you mentioned, Scott, is weight. Sensefly, since its dawn and continues to do so, is revolutionized fixed wing technology, but with a view of sub 2 kilo systems. 2 reasons for this: safety. and regulations. And we're seeing more actually for the European regulations. If anyone from here is operating in Europe or wants to operate in Europe, probably as of next January, if you have a system that's sub 2 kilo, the permissions will be a lot easier than anything over. So any VTOL, that you see on the market, as Scott says, the design, the added motors, the complexities that surround it mean it's usually 3, 4, 5 kilos, which means that your permissions are going to be hard to come by. The second thing, when it comes to wind resistance, as I showed you before on the software, the EBX uses the wind to help itself land safely. So it flies into the wind, obviously, to slow itself down. And the higher the wind there, so you're talking 12 meters per second, 45 kilometers per hour, it's flying into that wind, it's going to do an extremely safe landing, no issues. Whereas a VTOL, if it comes down with 12 meter per second winds against it, side wind type of thing, sometimes the drone is, and I've seen this before, physically unable to land, and that causes a real dilemma. The real horrible scenario a user will find himself in is, say he's just done that mission similar to what we planned on Emotion, where we've done 50 minutes. That's in line with one flight for a VTOL. We've only got 5 or 10% battery left to land. And then as we land during that 50 minutes, the winds have picked up to those 12 meters, and now we're physically unable to land. That means that drone's only going to be able to stay in the sky for a certain amount of time. And once that time or the battery expires, there's only one way it's going to come, and that's down. And you've got that 3, 4, 5 kilo beast coming down. So for us, we've always geared towards linear landings with our design, because of the safety features, because of the wind resistance, because of the weight factor. And obviously with the additional endurance, like I showed before, if you have got an area that you can potentially not land in, then maybe land or launch half a kilometer down the road, because as I said, the transitional period of the fixed wing is minimal in the battery it uses. So then you've got a lot wider area to be able to choose from. And obviously it's impacted on your regulations and whether you're doing EV loss or BV loss. But the simple fact is, with a linear landing fixed wing, there's a lot more advantages than with the VTOL that they try to preach, and that they can land and launch everywhere or anywhere, which unfortunately simply isn't the case.
Thanks, Chris. Thanks for that one. Moving on to the next question. Would you recommend drones over manned aircraft for large area survey, 100 square kilometers? That's a good question. You can think of it this way. You can use a multitude of these drones. You can have a team providing corridors or larger expanses of survey. That is a possibility. Manned aircraft is obviously another solution. But yeah, Chris, would you feel that multiple aircraft are capable of surveying such large surface areas, or would you say that's more for manned aircraft?
Yeah, I think the 100 square kilometer is an interesting point. Obviously, once you get to those type of data sets, which not too many other clients are doing, there is a question of whether manned aircraft is better or satellite imagery. But as I said in the Q&A, it depends really on several factors, and really depends on what the user needs in terms of the output files. What GSD does he need? A manned aircraft obviously flying a lot higher. Is that going to be sufficient enough? Price-wise, to rent a manned aircraft for one mission usually is in the tens of thousands, sometimes close to hundreds of thousands. So it really depends on the user's needs, the size of the area. 100 square kilometers is feasible with fixed wing. With our system, as I said before, with the Emotion, it allows you to do multi-drone flying, so you can do 2 or 3 drones at one time. And imagine if each of those drones is doing 5 square kilometers in one flight. That means in 1 hour or an hour and a half, you've done 15 square kilometers. Let's say you're mapping for 4 hours of the day. Already there, you're doing the lion's share of your 100 square kilometer project. So as I mentioned in the Q&A, I'd say that I don't want to say that it's definitely our system, because that's not to say. I don't want to missell, but I will say that our system there, like I mentioned at the beginning, is there to fill a void in between the manned aircraft, the satellites, the terrestrial, the quads, and it is a lot more flexible in what it's able to do. It can fly under the clouds so that you've got that on-demand data. It's covering those 5 square kilometers per flight, and you can do those multi-drone operations. So 100 square kilometers is by no means undoable with our systems. It's very much achievable. It's achievable also with satellite and manned aircraft. So it's for the client or for the person doing the job, it's about weighing up the options and seeing which is the best price, the best data, the best overall system to be able to acquire that type of imagery.
Thanks, Chris. That's great. What if the weather is bad? Can I continue to do my work? I think really you've got to look at it this way. Sensors are dependent on the conditions in which you're flying. So no matter what system you're flying, if you're considering sandstorm, if you're considering fog, if you're considering heavy rain, if the drone is capable of flying in those types of conditions, the cameras themselves will be limited to the footage they can take. So that's something to bear in mind. So we can't really put a black and white answer to that one. But all we know, compared to the competition in windier conditions, the EB will come out on top every single time. Another question as well, what's the map based on? Google Maps or something else? Chris, if you can answer this one.
Yeah, so what we're using is Microsoft Hybrid. That's our go-to background map. We found that was just more detailed than Google in a lot of areas. But again, there's multiple choice. I didn't actually show you in the Emotion software before, but there's different ones. There's Aeromap, which is for China. There's Digital Globe Satellite, and as I said, the ability to import your own DSMs and background maps is particularly useful when doing missions where you really want to have the surface or terrain data very accurate. So usually a lot of our clients are doing those higher altitude missions before going into their more detailed missions so that they have that up-to-date data.
And does it have elevation data for countries like Pakistan?
Elevation, we do, obviously. The elevation data there is available for Pakistan. Again, when it comes to some countries, some of the data might not be usable. It might be, again, too old and the terrain or, things may have been built in between. So when you're planning missions in the office, as I said, once you're on the field, it is about then assessing, well, once you're there, to make sure that everything that you've done is in relation to where you are. And again, if the data isn't sufficient, as I said, you can try and find some alternative means of satellite data that's more on demand. The country in relation, say Pakistan, for argument's sake, might have a source which is more up to date than maybe Google or Microsoft. And then again, worst case scenario, if you don't have that, you can do that, mission that's flying quickly over the area, process that and upload that to Emotion so you can work properly.
Fantastic. Thank you very much, Chris. If anyone else has any more questions, please fire them away now. But if not, what you can do is you can get in touch with either myself, Chris, or Dan in due course. I'll be following up this webinar with an email showing the PowerPoint presentation and also the webinar again if you want to revisit it. But I want to thank you all very much for joining us today, and keep an eye out on FEDS on the website, through social media, for further webinars as time progresses. I hope you've enjoyed today and learned a bit about SenseFly, about the EBX and the sensors, and also how to process that data. I want to thank very much Chris for helping me today to showcasing the Emotion software. Again, just to showcase, how great SenseFly are, very much customer focused, understanding what you guys need, what you want, how we can help you. So yeah, if that's everything, thank you very much for joining today. Chris, thank you very much. And we'll see you in the near future. Thank you for your time, everyone.